Hello. Today we're going to talk about Topic 1, Section 14, Matrices. So, matrices are just another way of organizing your data. So, instead of having a list where, just this long run of data, you can now make it two-dimensional and have rows and columns. Okay? So, here we have our schedule. So, Monday, Tuesday, Wednesday, Thursday, Friday, right? That's these columns. The columns represent the day of the week. And the rows represent the time slots. So we've got morning, afternoon, late afternoon. Okay. So here, the data entry is how many classes there are. One class, two class, one class, 1, 2, 1. One class, one class, one class. 2, 2, 1. Right? See how it follows that column. Okay. So that's just another way of organizing a schedule, right? Information. So again, we write it as rows by columns. Every time whenever they ask you the order of something, I want the row times the column. In case you ever forget, just remember my name, okay? It is Rachel Cross. So we're going to do rows times columns. So for example 1, we have rows are like a rowboat. So we have 2 rows, and columns, all right, like the Colosseum, are going to be vertical. So we have 3 of those. So our order is a 2 by 3. 2 rows by 3 columns. If you put 3 by 2, it is completely wrong. Okay? Example 2. So what if they say something specific like a subscript, B23? 23 represents the location, okay, where this is the row and then the column. So we go to row 2 and column 3, and we get negative 15. So the element of, well, I guess the element is the second row, third column. Okay? Okay, so let's see. What happened, or for example 3, we know that A equals B, so these matrices must be equal to each other. Well, if they're equal, then the elements in the exact same location must be equal. What I mean by that is x squared plus 1 must equal negative 17y. That's this one and this one. Okay? Kind of erase my 1 there. Do a little better there. Okay, then I know the second one here. Well, that's 2 equals 2. Well, that's kind of a given. All right, then here we have y equals y. That's not really helpful. But then we have x equals 4. That one is helpful. So now knowing x, we can plug that into our other equation. So for x, we get 4 squared plus 1 equals negative 17y. So that's just 17 equals negative 17y, so negative 1. So now we have x equals 4 and y equals negative 1. Okay, so the order of a matrix is 2 by 8, and the order of matrix B is 2 by 2x squared. Well, if the matrices must equal each other, then the order must be the same. So the order must be the same. So 2 and 2, well, that's good. The second part is going to be 8 must equal 2x squared. So we get 4 equals x squared. So x is either plus or minus 2. However, remember that x, you want to make sure that both of them work. So we think about how it's written. Well, yeah, how it's written, if I plug in negative 2, I'm not going to have any issues. So both of those would be right. Okay. All right, so let's do a word problem. Okay, So for this problem, this is a list of all the prices of, 3 products sold by 2 stores. Okay, and they're running a discount. So each item is being discounted by this much. So we want to find a new matrix that represents the final price. So what we have is our original one, 21.3, 45, 15.9, 22.5, 43, and 14.5. We're going to subtract our discount. So when it comes to addition or subtraction of matrices, you can subtract the elements as long as they line up. So what I mean by that is that this is 3 rows by 2 columns, so we can subtract 3 rows by 2 columns. Okay, it has to have the same order. So we subtract those, we get a new matrix. So let's see, 20.8, we get 43.6, I believe, 12.9, 20.1, I know, I'm going as fast as I can, 40.9, and 13.5. Okay, so that's a matrix that represents the final price of each product in each store. Okay, and that's how we show our work. Alright, so example 2. So here we're adding these matrices together. We want to find the values of A, B, and C. So I just start with the first element. So we have 2 plus A must equal 2B. That didn't get me enough information, so then I'm going to do the element below it. So A plus 0 equals A. Well, that was useless. Okay, A equals A. So then let's try the middle elements. So then we're going to have 3 plus negative 1 equals 2. Well, again, useless. Okay, I'm doing the middle elements. So negative 2, 1, and B. This one looks promising. Oh, not plus. Equals. So B is negative 1. There we go. I found one answer. So then I can actually go ahead and plug that into my other one and figure out what A is. So let's go back over here to the first column. So we have 2 plus A equals 2 times negative 1. So A equals, what is it, negative 2 minus 2, so A equals negative 4. Alright, let's match up the last one. So let's see, this is, wait, hold on. The only thing we haven't found is C, so I'm just going to jump to this one. 4 plus A equals C. If I can write correctly, that would help. 4 plus A equals C. So we know what A is. So 4 plus negative 4 equals C. So 0 is C. Okay, example 3, another word problem. Okay, so in this problem, we have our toxic emissions, and we want to reduce them all by 10%. So that means instead of having the original 100%, I want 10% less than that, so I want 90% of the original. So I want to take my matrix, and I want each one of those items to be reduced down to 90% of what it was. That means multiply each value by 0.90. Okay, so we're multiplying by 90%. And that's how we work that out. Okay, so let's see. So you don't have to listen to me do that. I'm going to write those down. Okay, and that's your answer. So that's called multiplying by a scalar. Ooh, my arrow didn't quite work out the way I wanted to. So that 0.90 is called a scalar. That's supposed to be an AR. Yeah, gotta work on my handwriting. Okay, so let's start with example 4. So here we're going to multiply and then set things equal. So k times x squared must equal negative 2y plus 1. We got that from the k times that element equals that. All right, that's a little complicated. I don't really have anything for that. So what about the next one? K times negative 2 equals x minus 1. We're getting a little closer. Okay, and then the other one, we have k times 3 equals negative x. And then the last one, we have k times 2y equals negative 10. So we have a lot of equations, right? All right, remember, all I need is, for a system of equations, I need 2 equations with the same 2 variables. So that's going to be these 2. Okay, so here I can think of this one as x equaling negative 3k and plug it into k. Or, I'm sorry, the green equation. So replacing x, so now we get negative 2k equals our x, which is now negative 3k, minus 1. So here we get k equals negative 1. So now it's all about plugging stuff back in. So now we've got one answer, plug it in there. That gives us x equals negative 3. Let's see, now that we've got k and x, we can go ahead and plug in other stuff. So let's see, for this blue equation, we can do negative 1 times 2y equals negative 10. So y should just equal 5. Okay, and all we needed was k, x, and y. Perfect. Let's see, next one. Okay, so a teacher gives a 3-part test to her students. So on the first part, they're awarded 1 point. Part 2 is 1.5 points, and 2 points on the third one, or the third part. So find the number of correct questions answered by 4 students is shown below. Right, so these are all the ones they got correct. Right, so this is what they got the point. So which student earned the highest combined score on the test, and state the total number of points. So the first thing I'm going to do is I'm going to write it as a matrix. Okay, so I just listed all the parts they got right, and then I want to multiply part 1 by 1 point, part 2 by 1.5 points, and part 3 by 2 points. So I want to do each column differently. So how I write that is I write it by times this. Okay, so I'm listing it in order like this, because when I multiply, all right, I'm going to take 18 times 1, and then I'm going to do 2 times 1.5, and then I'm going to do 4 times 2, and I'm going to add those together, and that's going to be my new element. Okay, so I'll go ahead and throw that away so you guys can see. So we did this row times this column. All right, and so that's what we got here for this first line. When we move it down, and so that's what got us here. All right, if I do the second row, I do the same thing. 10 times 1, 8 times 1.5, 4 times 2, and that gets me this one. Okay, I really hope this is making sense. So then I do this row times this column, and that gets me here. And just to finish it out. All right, so this was the highest, or these were their scores on the quiz. or I'm sorry, 3-part test, whatever it is. Okay, so this represents student A, B, C, and D. So the person who earns the highest combined score would be student D with a score of 31 points. Okay, so multiplying matrices. All right, it is associative, so it doesn't matter if we do A times B times C or A times B times C. Like this associative, it doesn't matter which two I multiply first, as long as it's in order. Okay, so, and then I can also use the distributive property. It's not commutative, which is what this shows. So if I want to do A times B, A is 1x 3, 7. B is x times 3. So we do row times column, right? Always think of my name, Rachel Cross, row times column. So this is going to get us 1 times x, so 1x, and then x times 3, so 3x. So our first element in our first row, first column of our new set is going to be 4x. We do the next one. So this row, I guess I should use a different highlighter. So this row, and still the same column. Okay, we're going to do 3 times x. Ooh, maybe not green highlighter. Let's go back to blue. So 3x plus 21. So we can't really simplify that, so we just leave it as 3x plus 21. That's that matrix. However, when I do BA, I have x3 and then 1, slanted 1x3, 7. Alright, now when I multiply this, I run into a problem, because when I do this row times this column, I can't do it. There's not enough values to match up. I have a 1 and a x that can line up, but there's nothing to pair with this 3. So I can't do this one. Okay? Doesn't work. Alright, so here we just want to multiply them out and set them equal to their counterparts over here. So practice multiplying, and then I'll show you the answer. So pause it. Okay, so again, I just multiplied each row times each column and got these red elements. So I got a 3 by 2, which is what it equals, and I set each of those elements equal to their counterparts. And now it's just a matter of solving. So I just pick stuff out and start solving. So let's do that one. Alright, that one's easy enough. That one tells me y equals -2. Okay, well, I'm getting closer to figuring out what a is. So I also need to figure out what x is. Let's see. Alright, we've got it here. We can solve for that. Get 7x equals, subtract the 5, 28. So x equals 4. So now we can take both of those and plug them in there. So we get 4 squared plus 6 times -2 equals a. So 16 minus 12. So a equals 4. So did I need every single equation? No, but I was able to, it was much easier to solve it if I could see what options I had. Okay, another word problem. Okay, so it wants us to write it as a 2 by 2 matrix. Oh, I should probably use a different color. Okay, so a 2 by 2 matrix. So 2 rows, 2 columns, and each row represents one factory. So I'll let the first row be factory A. So we'll let this be 452 wallets, and 270 of them was shipped. Factory B, we have 720 wallets and 514 of them shipped. So this is total and this is shipped. Okay? So let's see. It cost, now again, the A and the B and the W and the S, that doesn't have to be part of your answer. I was just showing you where I was getting my info. Okay, so you wouldn't need to put that as part of your answer. All right, so it costs each factory to produce one wallet and that much to ship it. So we want to multiply. We have 452. I guess I should have written it down here, but you know, lessons learned. Okay, and then we're going to multiply it by, well, this part was wallet, so I want to multiply the wallet by 1274. All right, that's how many I made. That's how much each one cost me. Then shipping times how much it costs for each one to ship. So write a matrix that represents the amount of money spent by each factory on production. So this is how we can find our answer. The wallets time how much they cost. So again, it helps to know how I wrote it. Sorry, so let me put the answer in. And that's the answers you should get when you multiply and then add. All right, so let's write this in expanded form. Okay, so I want to be very clear. You cannot distribute that squared because you are adding there. So if we were to rewrite this, it's a plus b times a plus b. So we FOIL it, and we should get a squared plus ab plus ba plus b squared. And that's it. There is no combining ab and ba because matrix multiplication is not commutative. These are not equal. So that's it. If you're talking about matrices, this is it in expanded form. Okay? Let's do part B. So we have 3i plus a, and then we're squaring it. I is the identity matrix. So I is a square matrix, and the diagonal is 1. So if I have a 2 by 2, it would be 1, 0, 0, 1. If I had a 3 by 3, it would be 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay? The identity matrix is kind of just like multiplying by 1 with regular numbers. Okay? When you multiply by the identity matrix, it doesn't change anything. Okay? So let's FOIL this out. So we get 3i plus a and 3i plus a. So we get 9i squared plus 3ia plus 3ai plus a squared. So the identity matrix, all right, when you multiply it by itself or anything, it's the other item. So I squared, so identity matrix times the identity matrix is just the identity matrix. Like 1 times 1 is 1. Here, identity times a is just 3a. All right, just like 1 times a. Here, a times the identity matrix is still just 3a. And then we have a squared. So here we have 9 times the identity. Now we can combine those and see 6a plus a squared. Okay, that's as simple as it gets. Okay. All right, number 13. So find the inverse of this. So how we find the inverse is first we have to find the determinant. So the determinant of a is, we do 1 times -2, so this diagonal, all right, minus the right diagonal, 3 times 5. So we get -2 minus 15, so -17. So the inverse of a, or as a to the -1, we also written that way, would be 1 over the determinant, so 1 over -17. And then what we do is we take a new matrix, you flip the 1 and the -2, and you change the sign for the right diagonal. So that's now -5 and -3. All right, so this is the inverse matrix. Now what that means, just like in multiplication, all right, if I have the number 5, the inverse, all right, think of it like the reciprocal would be 1/5, which would just get me 1. Well, similar to the matrix multiplication, the matrix times its inverse is just the identity. Identity is treated just like a 1, right? So let's confirm that this is true. So let's do the A matrix times 1 over -17 times this matrix. Now before I distribute that scalar, I'm going to leave that outside, and I'm going to multiply my matrices first. So 1 times -2, and -2, -15, so -17. Then I get -5 and 5, so 0. -6 and 6, 0. -15, -2, -17. Oh, would you look at that? Now I'm just dividing each one by -17, and it's the identity matrix. Yay! All right, number 4. So find the values of x such that A is not a singular matrix. All right, so a singular matrix just means that it doesn't have an inverse. All right, it's singular. You can't do the inverse. Not going to happen. All right, that happens when the determinant is 0. Because if you remember, the inverse of A is just 1 over the determinant of A times, well, sort of A, right? A new matrix A. All right, so it's not a singular matrix, so let's do the determinant. So 2 times x squared minus 2 times 4. All right, we want it to not be a singular matrix, so I don't want it to equal 0, so let's solve it. And we should get x can't be 2 or -2 because we don't want it to be 0. So x can't be these values, because if it was, it'd be a singular matrix because the determinant would be 0. Okay, so that would be a fun, or that was fun for a 2x2, but I really don't want to do anything past a 2x2. All right, because that's not going to be easy. So that's when we use our calculator. So get those out. Okay, so here we go to our matrix option. It's here, second x to the -1. So here we've got our matrices listed, but we want to edit them. So we go to edit, and we'll just make this matrix A, and it's a 3x3. So first you have to do your order, and then you just type them in, and you go like reading a book. So 1, 3, 5, 9, -2, 0, 2, 0, 1. All right, now I would always double check things, make sure it all looks good. Okay, and then we can second quit. So we want to find the inverse. So go back to your matrix, so second matrix, and now we see that we have a matrix. It's a 3x3. Hit enter. Now we have our matrix written there. If we raise it to the -1, that's going to find our inverse. Okay, and if we want to change those to fractions, we hit math, fraction, and it fixes it for us. See, isn't that just beautiful? All right, so then we just write this out here. So let me write this down. And really, that's all you need to put. Okay, I'm not picky here. I want to make sure you know how to use your graphing calculator. Okay, so take advantage of that. They're not going to be expected to do this by hand. So for here, you just want to show that we can write this as an equation. So when you multiply this out, well, yes, 2x plus 3y, that becomes 3x minus y, and we have equals to 7 negative 5. So there we can see that's how we get those equations. All right, so we can pull them back and go the other way. Okay, what I mean by that is here, list all your coefficients. So we're going to have 3, 2, negative 1, 1, 1, 1, and negative 2, 1, 0. Then we're going to have our variables, because that's what we had up here. We put them in order. X's were first, then Y's, then Z's. So X, Y, Z. And that's going to equal our constants. 4, 0, and 1. So if we want to get our variables by themselves, okay, we think about what we need to do here. We have A times X equals B. Right? That's how they wrote it over here. So these are matrices. I want to get rid of A. Well, I can't divide by A. I haven't taught you how to divide by a matrix. That's not a thing. But we can multiply matrices. So to multiply, what I'm going to do is I'm going to multiply each side by the inverse of A. All right, because when I do that, I get the inverse of A times this equals the inverse of A times B. Okay, notice how I'm writing it. Order matters when you're multiplying matrices. And so when you multiply the inverse times the matrix, you just get the identity matrix. Well, when that happens, all right, it's anything times the identity matrix is just itself. So X by itself is just the inverse of A times B. So let's go ahead and plug that into our calculator. So I'm going to clear this out, go to my matrices. I'm going to edit my first one. I'm going to let it be this matrix, so still be a 3 by 3, and type them in. So we've got 3, 2, negative 1. What's nice is that you don't have to clear them. You can just type over it. And let's see, so negative 2, 1, 0. Okay, then we can go back, so second matrix, and let's edit, I guess I need to go to the edit side. Let's do B is now a 3 by 1, and we type those in, so 4, 0, 1. And now I'm going to go back to my home screen, and I want to take the matrix A, so second, second, this one, enter matrix A. I want to take the inverse of that, and I want to multiply by matrix B. There you have it. So our system, okay, so our X matrix, our X matrix, so this X, Y, Z, we just solved it and got, didn't mean to do that. All right, 0.1, 1.2, and negative 1.3. So that means X is 0.1, Y is 1.2, and Z is negative 1.3. So to get this matrix to the other side, you multiply it by its inverse. Pretty snazzy, huh? All right. Yes, you could use the Systems of Equation Solver or the Poly Simulation app or whatever, but this is how we do it in matrix form. Okay? It's not that hard to show your work this way, so they might ask it. Okay, so let's see. This, like I said, they want to solve it using matrix equations. So we write this out. We have 3, negative 1, 4, x, y, 5, 7. So we need to find the inverse of that first matrix. So step 1, find the determinant. That's going to be 12 minus positive 1, so 11. Then we find the inverse, negative 111. And then we change it, so 4, 3, and we negate it. So positive 1, positive 1. And now we can multiply. So the left side is just going to be our variable, but the right side is now this inverse times our constants, 5 and 7. So I save my scalar for last because I don't want to deal with fractions. So let's see, we get 27, and we get, these are gross, 26. So here, x and y are going to equal negative 27 over 11 and negative 26 over 11. Okay? I really hope you caught my mistake right there. I don't know why I decided to multiply it by negative. No, it's 1 over the determinant. I've been doing perpendicular lines in my other classes. Sorry, so I was doing opposite reciprocals. Don't do that here. It's just 1 over the determinant. Don't know what I'm thinking. Okay, there we go. Next one. So, if we want to set this one up like we did the other point problem, right, with the quiz scores. So we're going to have 27, 24, 35, 9, 8, and 5, 2, 1, 1. Only problem is we don't know what these points are awarded. So we're going to label them X, Y, and Z. And then it's going to equal 289, 218, and 195. So practice this with your calculator. Okay, so plug these numbers in. So you want to do the inverse of this matrix. So this is how I can show all my work. And then I'm going to plug it all into my calculator. So that the inverse of this matrix, we do that negative 1 exponent. And then we're going to multiply it by the constant matrix. And then we're going to see what we get. Okay, so plug that in the calculator. Give that a go. You might want to pause it. All right, I believe it was 2, 15, and 50. That's what it said in Cognity, I believe. All right, next one. Okay, so another option here. You want to try writing this out, so you might want to pause it, give this a try, and then I'll put the answer. Okay, so when you write out your matrices, it looks like this. It's a 4 by 4, a 4 by 1. Make sure you change the order on your matrices so you have enough elements, and then you should solve and get this. Now notice how it asked for your answer. It didn't ask for a matrix, it asked for the number of calories in one apricot flavored bar. Well, the first thing, the X, was peanut, the Y was vanilla, the W was cherry, and here my last thing I inputted in my last column was the apricot. So one apricot is going to have 150 calories. So that's how I'd write my answer. I know, we're almost done, I'm sorry. So, encoding a message. Okay, so when it comes to encoding messages, the formula they had was E equals MP. If I can write. I'm also not even saying it right. EP equals M. I'm getting it. Okay, so what that means is we've got our encoding matrix times our unencoded message is going to get us our encoded message. So the encoding matrix, the one that's doing the work, that's changing stuff, times your message that's not uncoded, right? It's not coded, that's what I meant to say, equals the new matrix. So we want to prove that this is true, okay? That E and M are going to get you your P. So we need the P by itself. So to move E, we multiply by the inverse matrix. So we need to prove that P, this matrix, is equivalent to the inverse of E times M. Okay, and we can write that out in matrix form and then plug that into our calculator, and we can see that it's true. Okay. All right, so 7. So use the table and encoding matrix E to encode HL math L, or math, what is that, a 1? Oh, that's a 1. Okay, so our encoding matrix, our unencoded matrix, to get an encoded matrix. So we want a new encoded matrix. All right, something's got a special code no one can else figure out, right? So since this is a 2 by 2, I know that I need to multiply it by something else with 2 rows, right? This is the 2 columns, so you need to multiply by the 2 rows. So I'm going to rewrite this HL math, all right, as a 2 by 4. So what I mean by that is I'm going to say L, so you don't think that's a 1, MATH1, but since I have an empty spot, I'm just going to put a space. So that way the person I'm sending it to doesn't think that's an actual letter, right? But I need to finish the thing out, okay? So I could add space. So we're going to change these to the proper numbers. So H is 8, L is 12, M is 13, A is 1, T is 20, H is 8, 1 is 27, and space is 37. So we multiply by our encoded message to get our new message. So let's see. So you don't have to hear me say it out. You guys write it out, and then we'll compare answers. So pause the video. Okay, and that is how you encode your message. And there you go. Cryptology is really kind of, I don't know, it's a fun thing. It's all about decoding messages. You can, what's the word I'm looking for? You can do a lot of things with this, and it can go obviously a lot further, a lot more complicated with it, but this is how we transcribe messages and we send them. I mean, this is how we do things still to this day. So our enemies can't get our info, you know? All right, so this is everything you should know for this section. Hopefully that makes sense. Let me know if you've got questions.